So my research focuses on trying to understand broadly how volatile compounds like CO2 and water get stored and transferred between Earth's major chemical reservoirs, so being the Earth's mantle, the crust, and the surface environment, so the oceans and the atmosphere. And one of the major places where that chemical cycling happens is at subduction zones, so where one tectonic plate is sliding below another one and diving into the mantle. It depends on the time of year, I guess. So I guess a typical cycle would be, say, in the summer, I go off and collect samples at my field sites. And for my research, that would be in the Peruvian Andes. So last summer, I got to go down to Peru, spend a couple weeks there, and collect spring water, spring gases from hot springs. So it's pretty neat to be able to go from hot spring to hot spring. And then also to some lava fields where I was looking for those xenoliths I mentioned. So that'll happen in the summer. And then maybe the fall semester is largely spent in our geochemistry lab analyzing those samples for stable isotopes and other geochemical things. And then, say, in the spring, I might spend most of my time either analyzing that data, writing it into a manuscript, or writing grants and that sort of thing. While we're going around sampling springs and things like that, we do a lot of just understanding the chemistry of the waters. So we might find something like really high arsenic levels in the waters, and then there might be communities who use those water sources. So we have an opportunity to be able to sort of share our results with the communities who are affected by those water sources, and we can alert them if there's anything to worry about. And then also a lot of my research will sort of bleed into fields like climatology, because like I said, one of the volatiles we are interested in is carbon and CO2. And while most of what we focus on right now is anthropogenic carbon release from humans and all, a big part of those models and things like that is understanding the natural carbon cycle and the geologic releases of CO2. And the stuff that I work on has components, or some of the CO2 might be coming from, say, my field areas along these volcanic arcs in Peru. So it helps to sort of understand natural sources of CO2, which obviously can affect the climate in the long term. I guess especially if they're coming for a PhD, I would implore them to make sure that they were really interested in their research and that it excites them, because it will be obviously a major part of their life, if not an all-consuming part of their life, for several years, a good chunk of their life. So I would say interest in your research, and also making sure your project is clear and that you get along well with your advisor and mentor is also a good idea. Sure. I think I really want to continue my research. And that could be working at a university as like a faculty member, or also working for federal government, be it the United States Geological Survey, USGS, or maybe for the National Park Service. In most cases, that would mean doing a postdoctoral research position first. But yeah, just kind of continuing on this path, I think is sort of what I'm excited about.